David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen.
Today's topic is experimental probability. Now, you'll remember from our last lesson we focused in on theoretical probability that has to do with things like dice and coins and cards, where the probability is known and we can figure out probability of certain events or combination of events just because we know theoretically what the probability of those things are. Experimental probability is things that we can't know theoretically. For example, like shooting an arrow at a target. We don't really know the probability that it'll hit the center. So we can use experimental probability to figure out things like that. So one of the key terms in experimental probability is relative frequency. So what that means is it's the number of desired outcomes over the total number of trials. So let's say I shoot an arrow at that target 38 times and I hit the center 4 times. So the relative frequency of hitting the center is 4 out of 38. And we can use that as the rough probability that on the next shot, I'm going to hit the center. So that's how we use theoretical probability to make predictions about the future. So let's dig into this a little bit more. How about this one? What's the probability that a stranger likes blue? So I'm going to stand in a shopping mall and ask 500 people that walk by me, yes or no, do you like blue? And I'm going to track the number of people on top. These are the people who do like blue. And then these are the total number of people that I've asked about color. And that's going to give me the relative frequency of people who like blue. Now, experimental probability can be used in a lot of different types of situations, and they can get a little tricky. So you got to use your critical thinking skills to dive into the problem so you're sure that you do the right math to get to your answers. Here's a classic experimental probability type of question. So, standing on a busy street, what's the probability that the next car to drive by me is red? Now, I can just walk up to that street and make a guess, but I need to collect some data via an experiment before I can really answer this question. All right, let's say I just stood on the street corner for several hours. I counted the cars that went by and I noted their color. And I put my data in this table over here where I'm tracking red, black, white, green, yellow, blue, and then other colors. And I have my frequencies here. So this means I saw 26 red cars, 18 black cars, and so on, for a total of 110 cars that I counted. Now, the relative frequency, remember, it's the desired outcome over the total trials, the total number of outcomes. So I got 26 out of 110 red, 18 out of 110 black, 20 out of 110 white, and so on. So each color has a relative frequency. Now, since our question is about red cars, we're going to drill in to the red car relative frequency. Your first question, what's the probability that the next car to drive by is red? I want you to pause the video, use this information, and calculate that probability. So in this case, it's pretty straightforward. We just use the relative frequency to predict the probability that the next car will be red, because we know that 26 out of 110 cars in our data are red, so we're going to use that to say the next car has a 26 out of 110 chance, which is 0.236 or 23.6% chance of being red. All right, let's now do a calculation with expected value using experimental probability. So here's your question. If 150 more cars passed by, how many would you expect to be red? Now pause the video. You might want to flip back to your notes from the last lesson to answer this question. If you remember how to calculate your expecteds, you use this equation. What are the expected number of red cars? It's the number of cars that pass by times the probability of red. And we figured out our probability of red by using the relative frequency of red, which was 0.236. So we multiplied our n, which is the number of cars, that was 150, times our 0.236, and that gives us 35.5 cars. So there you have it. Okay, so with experimental probability, more data, more beta. So what you like, if you can, is to get a lot more data, because then that kind of refines your experimental prediction. Remember, this is an experiment, so it doesn't go the same every time. There's like variations in there. You could collect data over a whole year's time. That might be great, but we don't have that luxury. What we do have is that someone went out on the second day and counted the frequencies of each of our same colors. Again, I just added them to this side of our table, but it's the same data. And here's your question. A second day's worth of data is collected. Find an improved estimate that the next car passes will be red. Now there's a little bit of critical thinking here. The math, the computation part is pretty straightforward. Pause the video and see if you can come up with that improved estimate. All right, let's see how you did. The trick here is to treat both days of data just like one experiment. So what I did is I added up however many cars we counted on day 2 and combined them with the number of cars we counted on day 1 for the bottom of my fraction. So that's 110 plus 92. So the bottom of my fraction is 202. And then I just added up the red cars with day 2 and day 1 on the top. 20 plus 26 is 46. And then I just did my math. 46 divided by 202 gives me 0.228 or 22.8% chance the next car coming by will be red.
Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.